Hi, we're going to take a look at the video from an FRQ from 2002's AP test, problem number 3. It's about runners at New High School, and they are racing, and you get an information about each one of the runners on their team, the mean and standard deviation. They do tell you that each one of the runners follows an approximately normally distributed in terms of their race times. So for part A, it talks about runner 3 and runner 3 only. And he thinks he can run a mile in less than 4.2 minutes, and is this likely to happen? When you see the word likely, you need to make sure you think of probability. So this is actually asking you to calculate the probability of runner 3 being less than 4.2 minutes. So what I'm looking for in the solution is, do you recognize that it's a normal model? All right. And that means you need to have n, and then the mean and standard deviation for runner 3 would be 4.5 and 0.14. That's missing here. Okay. Now the AP might take it because they're listed over on this side, but remember, for us, I want you to do it the way that I've taught you. This is the classic way of denoting that you're working with a normal model, so that's what I'm expecting from runner 3. Now I'm also looking for shading. Have you marked what 4.2 is? Now this person has marked 4.2 and they've shaded to the left. So this point is going to get the shading credit for this particular problem, but you can see there's other things that I would like to be there. There needs to be like a horizontal axis, there need to be labels and all that good stuff. It could fix it up a little bit, but I'm looking for only those two things in this particular problem. Now the next thing I'm looking for is P of x being less than 4.2. Now this person used less than or equal to. The AP actually is not going to take off for that. I would like you to be right based on the wording of the problem, but the AP is going to give credit for that. All right. The better thing would be, it says less, not less than or equal to, so less than is the best symbol. And the next thing I'm going to need to see is P of z. Now they did the z-score, incorporated it within the P of. Our z-score is probably going to be calculated x minus mu over sigma, and you're going to do the work over to the side, and you end up with P of z being less than negative 2.14. Check. The next thing I'm looking for is the normal CDF, which is missing here. Normal CDF from negative 999 to the z-score, which is negative 2.14. That is missing. And then the final answer is 0.0162. They do have the correct answer, and I love how they wrote some stuff about it, and they made sure that it was very clear in their answer. If you have time, that would be always a nice thing. Just make sure you keep it in context. There are 6 checks right here for this particular problem. All right, my person got 4 out of the 6 checks. Now moving on to B, it says the distribution of possible team times. That means all people on the team is approximately normal. All right, so you're putting together 4 normal things and you're getting a big normal total time thing. So what are the mean and standard deviation for this distribution? Well, remember, means are additive. So what I'm looking for is, do you have the right symbol, mu? Do you have the right work? Did you add up all the means together? And do you have an answer of 8.9? Give yourself a check. I would love units to be there, okay? The units would be in minutes. I'm not giving a check for that. It'd be better if you had minutes as units for both the mean and the standard deviation. Now the standard deviation, okay, we have to have the right symbol, all right? So I see the standard deviation here of sorts. Now what I'm looking for here is the Pythagorean theorem of statistics. And you'll notice they did it in terms of variances. So if I take away this little square right here and put the square root around, it means the very, very, very same thing. They have all the standard deviations squared and added together. I'm not quite sure what this thing is going to be. All right. So I'm going to give them credit for the work. All right. They did it in terms of variances, but I fixed it for us. And then the answer for the standard deviation, this is the variance, so I'm going to sort of cross that out. But the answer for the standard deviation is 0.3003. Okay, so that means this is worth 6 points. My person did get all 6 points on this particular problem. Okay, now for part C, it says, suppose the team's best time to date is 18.4 minutes. So this is going to be the team issue going on right here. This is about the entire team. We're going to be using the answers from part B because part B is all about all 4 runners on the team. What's the probability that the team will beat its own best time? Okay, so we know it's a normal model. The N needs to be written there. The mean is 18.9 from Part B. The standard deviation is 0.3003 from Part B. My person does not have it, so that is an X. All right. Now, they do need to make a note of and mark the 18.4 minutes, and we want to say they're going to beat it. So 18.4, I would prefer if the 18.4 was underneath here. Now, beating the time in running means they ran faster, so the shading has to be to the left. And that is a common mistake. You think you get a higher number would be better, but when you're racing and stuff, a lower number is better. So we're going to shade to the left. Now we're going to have P of, they use T is less than 18.4, check. P of Z being less than negative 1.67, check. The Z-score, show your work for the Z-score, all right? So you go ahead and show your work. I'm not going to give a check mark for that. I would love to see the work. The next thing I'm looking for is normal CDF from negative 999 to negative 1.67. That is missing. And then the final answer is 0.0475 about. Okay, a check mark for that. There are again 6 checks on this particular problem. My person got 4 out of the 6. This has a total of 18 points. Let me scoot that over. 18 points. All right. So my person only got 14 out of the 18. I'm going to put a big box around it, as you should do too, and that is the grading for the running problem. Thanks.